Number 34, calculate the mole fractions of methanol, which is CH3OH, ethanol, which is C2H5OH, and water in a solution that is 40% methanol. Okay, we got 60%, just kidding, 40% ethanol and 20% water by mass. And I just want to color code this better. I tried doing it, but I put the wrong color. So blue goes with blue. Methanol, CH3OH, is 40% part of the solution. We have a 40% ethanol solution, part of it, and we got 20% of the water. And this is all by mass. Now remember that mass means that we're talking about grams. And they say that assume the data are good to 2 significant figures. Generally, at the end of the day, the mole fraction should be 2 sig figs. Okay, so they gave us a solution here. A solution is just basically a bunch of substances mixed into one another. In this case, we have 3 different components. We have a methanol, an ethanol, and the water. And we have to find the mole fractions for all 3 of these. But they only gave me percents. So let's just list this out. We have 40% of the methanol, which is the CH3OH. Okay. We have the ethanol, which they said was 40%. And that's they actually gave it to us as C2H5OH. And then they said we had water, which is the remaining 20%. If they always give you percents, just to make sure that there's no hidden percentages. Remember that the total percentage always should equal 100%. So 40 plus 40 is 80, plus 20 is 100. So no hidden percents here. Now we're ready to start the problem. Now in this case, we want to find the mole fraction. Let's just post up the formula for what a mole fraction is. It's this right here, right? The capital X value, and I'll put this on this side, capital X is the mole fraction. How unique? I do not know why it's capital X, but we'll go with it. So a mole fraction is just a regular fraction. It's a part divided by a whole, right? The difference between a fraction and a percentage is that one is times by 100, the other one is not. But in this case, it's no different. That if you want to find a mole fraction of a certain compound, we have 3 of them here, we would have to take the moles of that specific compound and divide it by the total number of moles in the whole entire solution. But mole, percent. Yikes. We have to get it into moles. We're not in the correct unit. But they gave us a hint here, is that all these percentages are by mass, which we can convert into grams. Now, we can assume that the total percentage that we have, right, which is 100%, is going to equal the total gram sample that we have. So 100% equals a 100 gram sample. So that means that if we're assuming that 100% equals 100 grams, the percentages that we have here is going to equal the grams. So 40% is going to equal 40 grams of CH3OH. 40% of C2H5OH is 40 grams of C2H5OH. And then 20% equals 20 grams of H2O. Now we have grams. We still need to get to moles. But that's back to basics, right? Way in the beginning of chemistry. If we want to convert from a gram of a substance to a mole of a substance, all we have to do is take the grams and divide by its molar mass. So let's just maybe do some arrows here and say that we want to go from grams of CH3OH to moles of CH3OH. Grams of C2H5OH, we want to go to moles of C2H5OH. grams of H2O, we want to go to moles of H2O. And for each one, we have to divide by the molar mass. So let's find out what the molar mass of CH3OH is. I got 1 carbon, so that's a 12.01 on my periodic table, plus a total of 4 hydrogens, so I'll group them together. 4 times 1.008, and then you got 1 lonely oxygen, so that's just a 16. 12.01 plus 4 times 1.008 plus 16. And all the numbers look good to me. So I'm just going to take the 40 and divide by 32.042. 40 divided by that number is, maybe I can move this up a little bit. Whoop, what just happened there? I want to move maybe this up to move this a little bit out. Okay. So total number of moles here is 1.248. That looks good. Let's do the same thing now for the ethanol, C2H5OH. You have 2 carbons now, so 2 times 12.01 plus a total of 6 hydrogens, so 6 times 1.008 plus the 1 oxygen, so that's 16. 2 times 12.01 plus 6 times 1.008 plus 16. And I'm going to take the 40 grams and divide it by 46.068, because that's the molar mass. And I get 0.868 will do, moles of the ethanol. One last one, we just got to find the molar mass of H2O. So 2 times 1.008 plus the 16. 2 times 1.008 plus 16. I'm going to take my 20 grams and divide it by 18.016. So 20 divided by that number. And we get 1.110. Okay, so maybe what I'll do is I'll just move them a little bit. Okay, so now we have the individual components, right? That's the numerator. The moles of the specific compound go on the numerator. So let's start making our mole fractions. So we have the mole fraction, capital X, for CH3OH. And then we have the mole fraction for C2H5OH, the ethanol. And then we have the mole fraction for H2O. And each one of these is going to be some fraction, obviously. And if we're doing the mole fraction for methanol, CH3OH, the 1.248 goes on the top because that's the number of moles of the methanol. For the ethanol, the numerator would be 0.868. And then for the water, the numerator would be 1.110. But the thing is, what is going to be the number on the bottom? The denominator. That's the total moles in the whole entire solution. Well, we have this amount of moles of methanol, this amount of moles of ethanol, and 1.110 moles of the H2O. How are we going to find the total? Yeah, you got it. We just have to add them up. So if we add these all up, 1.248 moles plus 0.868 plus 1.11, I get roughly 3.226 total moles. And that's the denominator for each one, because that's the whole. Fractions are always part over wholes. Okay, so now, let's give myself some space. Okay, and now let's just set it up. So the mole fraction of CH3OH is going to be just one number. And then we have the mole fractions. Okay. The mole fraction of C2H5OH, and then the mole fraction for H2O. Okay, let's do the math now. So 1.248 divided by the total moles. That looks good to me. And now we should have 2 sig figs. So this should be 0.39 as my mole fraction for the methanol. So let's box that off, one answer down. And keep in mind that mole fractions have no units. They are unitless. Now let's do the ethanol, 0.868 divided by the total moles. 2 sig figs, 0.27. 2 answers down. And if we just multiply these by 100 in our head, we can kind of see the percentage as to how much these are in the total solution. And then let's do the last one, 1.11 divided by the total moles. And we get roughly 0.34. Let's box that off. There's your 3 answers. And now, since we have 3 components in our solution, we could always do a check. Because if you add up all of your mole fractions, what total number should we get? If I add up all these numbers, this plus this plus this. The highest fraction of them all is 1 divided by 1, which is 1. And there it is. So check is perfect, and we are good to go. What'd you think? I hope this helped you out. Let me know in the comments. Thank you so much for viewing the video and for being part of this community. My brother and I, we truly appreciate you guys, and we're so glad that you can use this channel to help you out in your classes. Tons of videos, tons of topics, all just for you guys. So use the channel, take your time, and we'll be here every step of the way, okay? All right. I'll talk to you soon, okay? All right, bye-bye.